Hey everybody, I am Kenny. This time around we're going to be talking about XNA, so that's kind of the game developer side, so we'll be walking through some of the different scenarios that you can do there. So kind of on what you can do on either side. Seeing as we have about an hour for the session, we're not going to get into certain aspects of XNA, which is why we have tomorrow. So if you want to do anything with game development, if you want to do some of the different scenarios, because I'm going to be talking about some of the different sensors, the different pieces of hardware inside of the device itself, if you want to work more closely with those, happy to work with you on that tomorrow. I've got a bunch of different things that I've got working on here that I can share with you that I'm going to be posting online. Like I've got a augmented reality toolkit that I'm working on that's on CodePlex. We just did an update on that one as well. So if you want to see any of that kind of stuff, tomorrow. Cool. So going through XNA for Windows Phone, again, that's my email address. So this time around, we're going to start off by talking about some of the different available sensors and tools, the different hardware that you have, the different software that you have to work with these things. We're going to walk through the game loop. It's a little bit different if you have been used to doing some of the event-driven things with Silverlight or some of the other developer environments out there, because it is from a different world, essentially the world of game development, where you have to worry really a lot about performance. And one of the trade-offs there is that you actually do a lot more things inside of the code that you would normally have kind of just let the framework take care of in other things like Silverlight. So we'll go through that. We'll show how to basically start drawing something onto the screen, add some movement to it, add a little bit of sound to it, and how to do some combined Silverlight and XNA framework rendering so that you can do things like have 3D in a Silverlight application or have UI and controls inside of an XNA application to make those a little bit easier. So we'll see how that all kind of ties together. Okay, so to start, this is the Windows Phone hardware. You've got a 480 by 800 display, standard across every phone in the environment. So you may have a slightly larger or smaller physical display, but you're always going to be running at that 480 by 800, which is great for doing things like games where you would have different size graphics, different size textures and resources and everything that you would have to bring in to be able to support every different environment. But because you have that one platform, the one resolution that you have to program against, your resources are greatly simplified. You've got capacitive touch, so you have to have at least 4 points of touch to be a Windows Phone, which means that you have a great way to interact with the device itself. So we'll be showing a little bit about that, how you can get access to the touch points and how you can do some things with gestures. We have sensors like a GPS, accelerometer, compass, gyro, and you can combine some of those different things to make a kind of more usable without having to write as much custom code type of system through the Motion API. We have a camera. You now have the ability with this latest version to actually get a live stream from the camera. So great for doing some scenarios like augmented reality. You have the hardware buttons on here, the back button, the start button, the search button. You can control what the back button does inside of your game. So if you want to have that pause, if you want to have that actually do something inside of the game, you can do that using that back button. It doesn't just have to navigate back. You've got some multimedia specs so that you know that you have at least a certain amount of hardware behind your game. Minimum amount of memory, a minimum GPU, so it has to support DirectX 9 acceleration. And the CPU, you have a minimum on that as well, and we have some new profiles for that coming out with some of the newer phones here. On the software side, XNA was built to develop games. It was originally kind of concepted around the Xbox to be able to develop and deploy into the Xbox indie games marketplace, which you actually still have the ability to do. So if you were going to be writing a game, your App Hub membership that you would get to be able to publish games also works to be able to work inside of that side. So if you wanted to do some stuff for the Xbox 360, you've already got that ability once you're starting to work with some of the phone stuff. It really makes it easy to work with graphics and the entire graphics platform. I'll show how that works. You have some effects that you can work with, including some things like shaders. We've got some of the pixel, like the sprite effects, the font effects, all of those things that you've just got built into the system. It integrates directly into Visual Studio, and you have some audio support in there so that you can do things like the background music, sound effects, and in fact, if you're going to be working with a lot of audio in a Silverlight application, The easiest way to do that is to bring over an XNA library and use the XNA libraries framework to be able to play that audio, because it's just that much easier. So briefly through this, gets you everything that you need. You've got a content manager through a separate project inside of the same solution. By default, like just the stuff that comes with a new project, it's all set up to do 2D sprite-based gameplay. You can add in some stuff for 3D, and it has the ability to support models in multiple different formats, a lot of which you can export into if you have a model in a different format. So you do have common behavior that is as familiar and actually shared across the platforms as possible. I mentioned in, I think, the first presentation about how like that back button, the way that you handle that is the exact same way that you would handle the back button on a gamepad for player one. So you have the ability to do that. And the object model was built off of some existing platforms for game development, so it makes it really easy through the inheritance system that it uses to actually include that and build a game based on top of that framework. So for 3D games, we're not going to go into this too deep today because it is a lot more complex than the 2D games, just based on the fact that you have assets, animations, you have rigging, you have model. Like, you have to bring a bunch of stuff together to be able to even just show something on the screen, whereas I can do that in just a couple of minutes, and in fact will, with a 2D game. So with the 3D side, though, you do have hardware acceleration that you can get access to through that DirectX framework, and that's what actually enables you to do this. And you can use a bunch of pre-built-in shaders on the Windows Phone that allow you to do the lighting and the actual rendering and the texturing on here. One of the questions that I get pretty often, so I'll just go ahead and address it right now, is can you use custom shaders on the Windows Phone? Right now the answer is no. We have a set of shaders that support a majority of the actual instances that you would be able to use. The reason that we do not at this time support custom shaders is primarily around the level of access that you have to the hardware to be able to access those. It would give you the ability to go outside of the actual framework. So we've got some of those built in. We do have some resources available for you to be able to let us know what you need that we don't have provided for you. So if there's some specific scenario that you're thinking of that would be benefited from some additional thing inside of either the shaders or anything else inside of there, you can go to that. It's off of the user voice website. So if you look for Windows Phone 7 developer user voice, you'll be able to find that and be able to place your vote as to what we should do next. There's also a consumer side for that, so if there's something that you want on the consumer side, not as a developer, you can also vote up features there. So all games do just a few things in order to actually create kind of the game. The first thing they do is they load content, then they update everything, and then they draw it to the screen. They do some type of output. So in this case, what you've got is you have kind of where you're initializing the engine, loading some resources, grabbing the user input, doing some calculations, making sure that everything's good, giving some feedback, and then looping back in through there until the game is over, in which case you free all of those resources. But essentially, you load stuff, you update stuff, you draw stuff. On the XNA side, you basically have a method called initialize for initializing all your variables. You load content in the load content method, really well named there. Update's done in update, draw is done in draw. Again, the naming is really good. And then you unload content in the unload content method. One point on here is that this loop that goes through the update and then the draw happens every 30th of a second. It'll do it 30 times a second as long as it has the ability to do so in that amount of time. So if you're running something that has complex calculations, or you're doing something that's just really not that efficient, you might not be able to finish in a 30th of a second. If that's what you're targeting, if you're targeting a 30th of a second, it will actually skip one of those two. It'll either skip update or draw. Which one? Draw. Because if you skipped update, it's going to draw the exact same thing that it did before, so why would it skip draw? Or why would it skip update? So you want to skip the draw phase on there because the update is the more important of those and generally should be also the less processor intensive. So anything that actually matters to your game, collision, input, AI, anything that actually matters, all goes into update. Everything that is just drawing stuff to the screen should be done in draw. It's really tempting to put some stuff that actually does update things into the draw, because it kind of is grouped with the rest of the stuff. So like update the position and then draw it. Don't do it. You want to do it in update and then do it in draw. You don't have to actually have any output to have a fully functioning game, but it helps to actually be able to see what you're doing inside of that fully functioning game. So you want to do everything inside of update and then only draw in draw. That's why it's called draw. So to create a game world, you start off with a bunch of stuff inside of variables and load those into the content, initialize all of the base states, and then start running all of the update stuff to update their values. Draw just pushes stuff out. We're going to be building a game today built around cheese. If you know Rob Miles, you know that he loves cheese. So he's got a few samples that we're working off of that have to do with that. So we're going to be doing some different variants of working with cheese in the game environment. So first thing that we're going to do is a game called Cheese Roller. And essentially what we're going to do is we're just going to manage where that actual picture is and draw it onto that screen. So let's start off by drawing the cheese. All right, so first thing I will do, so if you saw the session, like the one before this one, you notice that I actually tried to do the debugging inside of there, so I left this open for this. I was in the wrong file. It's this location task agent right here, task scheduler, which is why I wasn't able to find this thing right here, and I thought it was just the big text, but it wasn't that. This is where it's at. So if I actually do the start tracking and exit out of this one, this one is the one where I was trying to find out where it was. It'll run now. All right, so while I'm building the other one, it's in the back of my eye. Okay, I'm going to do new project. Previously, we did all the stuff inside of Silverlight. This time around, we're going to do XNA Game Studio 4. So I am running the ultimate version of Visual Studio, and I'm also running a bunch of other stuff that's inside of here. But everything inside of XNA Game Studio came with the phone tools. So you'll notice on here that I've got a phone game, I've got a phone game library, I have Silverlight and XNA kind of stuff, but then I also have a Windows game and an Xbox 360 game, and then some content pipeline stuff. You get this inside of the phone tools because it comes with all of the Xbox 360 and Windows game development stuff for XNA. So you don't have to download a separate tool to do those, although you can. You can get the C# Express and get the XNA tools separately, but you're already going to do the phone stuff, you've already got it, you might as well just work with what they give you. Did this work? Not yet. Where's it at? Nope. It'll get there. It'll do it. Yeah, there we go. It broke. So there's my task. I got all that stuff. Ta-da! Debug. Okay, I'll close this now. Because it worked. Okay. So we've got all this kind of stuff on here. I'm going to choose a Windows Phone game. And it's going to be the Cheese Roller game, so I'll just call it Cheese. And 7.0 or 7.1, 7.1. We like mango stuff, so let's do that. Okay, so this is what we start with. We actually start, compared to the Silverlight application where we started with a single project, XNA gives you 2 projects. The 2 projects that you get are the default project for all of your code, and then a second project for all of your content. The way that it works is you actually do all of your content like graphics, audio, models, all of that into that content project so that it can process them ahead of time and give them to your other application as a resource. So for example, if you drop a certain type of audio into it that's not traditionally supported, you can have a converter on there. It'll do all of the processing on the audio file, and then when you get to the other side, it'll just treat it like a sound effect. It doesn't matter what the source was. They're all the same once you get to your actual code, so you don't have to worry about doing anything differently once you get to there. So you have those 2 projects. Inside of this project, the Cheese project, you've got a lot of stuff that you see already in Silverlight. So you've got background, you got your thumbnail, all these things. But you have program and game. Program, we don't care about on the phone. It's only important for the Xbox and the PC. Game is really the one that we want to look at in depth. So for game, it inherits from Microsoft XNA Framework Game, and this gives us everything we need for loading all of our content and going through those loops. So let's take a look at this. We get 2 variables by default. One of them is Graphics Device Manager Graphics. That is the thing that abstracts all of your graphics away so that it doesn't matter what platform you're on. You just say, graphics, draw this, and it figures out how to interface and do that. You get a sprite batch for drawing two-dimensional sprites, because even if you're working with a three-dimensional game, there's a very good chance that you're going to do something with two-dimensional sprite drawing, because that's how you can draw text. That's how you can draw two-dimensional things like a heads-up display. So you'll probably want that, so it comes with that. You can get rid of it if you really want to. And then inside of the constructor, we're going to initialize our graphics, and we're going to get our target frame rate. So for the Windows Phone, the frame rate is 30 frames per second by default, and that is the maximum for the devices that are available right now. So if you try and actually bump this up above 30 frames a second, it'll ignore you and go to 30 frames a second. If you try and put it below 30 frames a second, it's fine with that. If you only need 15 frames a second of updating, that's actually sufficient for your game. Then that means that you're just going to be running with less CPU, less battery power inside of it. So it'll actually run more efficiently if that is sufficient for your game. So you can do that if you'd like to, and it'll actually end up being a more kind of a nicer citizen in the terms of the device that you're working with. And then here's some stuff on here. We've got an inactive sleep time for some battery life on that one. We won't go too deep into that guy. So here's my initialize. So anytime I've got any custom variables that need to be initialized, I'll do it here. My load content for loading content from that content project. My unload content for unloading content from the content project that is not used with the content manager. So it's for custom controls and stuff. You probably won't do much with that. And then here's my update and my draw. So here's the update I mentioned on here. If gamepad.getState playerIndex.1 buttons.back equals buttonstate.pressed. So it's actually doing some polling. Every 30th of a second, you check to see what the current state is, and then that's when you do something with it. So instead of waiting until you get an event that says the button was pushed, you have to check every 30th of a second, is the button pushed? So it's one of the things where you're telling it exactly what to do, so it doesn't have to do all of that work on its own. So you have complete control over what it's doing, which makes it more efficient. It also makes it, in some cases, harder to work with, which is why we did the Silverlight plus XNA thing that we'll be talking about later, because you can actually do events and you can drop buttons and you can do stuff like that to handle the UI. And then you can do all of the other stuff when you need to handle everything custom in the way that you would expect. So that will just exit the game. And then right down here, I've got my draw. It's just clearing the screen. So let's go ahead and run it right here, see what we get. Let's see. All right, blue screen. What's up? No, so setting the frame rate right there, so the question was just what, if you set the frame rate, does it set your timeout? Your frame rate is just going to be how often it calls the update and draw. So if you have your frame rate set to 30 or like 15 times a second, or 15 times a second, so yeah, 15 times a second. Yeah. Anyway, whatever you set your frame rate to, if you have extra cycles when you're done with your update and draw loop, it'll just wait until the next time that comes back up before it goes back to the update and draw. So that is the maximum number of times that you're going to call that within 1 second. So if you have it for 30 frames a second, you'll only call that 30 times, even if you could do 60. So you can push it above that on certain, like if you're doing the PC or the Xbox, you can get higher than 30 frames a second. Phone, right now, with the devices that are in the market, I believe that all of them have 30 as their maximum. There was a talk about 60 for some of them, but only in certain states, like if we had it plugged in or something like that for performance. Because it really is, if you are doing something as simple as, simple in kind of our thoughts, as taking a JPEG, rotating it, drawing it to the screen, that'll kill battery life really quickly if you're doing it 60 times a second. Yeah. Okay. One more question over here? Yeah? Okay, so the question was around if you had a kind kind of a threading handled automatically by XNA. You've got the update draw methods on there. Is there a way that you can keep the UI thread responsive even if you're doing some kind of processing? You can set background threads and have them do some things outside of the update draw loop. But the update draw loop, like, it's going to run one, then the other. You don't get the crossover between them. So as I mentioned, essentially, if you don't have enough time to run both of them, it'll skip your draw. You'll drop frames. So if you have something, an animation of something moving smoothly across the screen, it might jump to another one if it skipped enough of these draw frames on there. So it does not force it to be smooth movement across there. You do have the ability to come back and say, what is the amount of time that has elapsed since the last time that I was called? So you can do some handling based off that. And you can set it so it's a fixed movement, so it only moves when that update method gets called. And so instead of moving at a constant rate across the screen, it'll move only when it's getting that update cycle. When you're running into a bunch of those, there are some performance articles up on the App Hub, and you can see some of the recommendations there. I'll go through a couple of them briefly as we're going through here. But the primary thing is you have full control over what you're doing inside of there. It's not going to automatically handle anything around keeping your application responsive. If you're doing something that is taking too much of the processing, you're going to see. You're going to notice it in there. Okay. All right, so I got this blue screen here, which is actually a good thing because it means that you know that your application is running. I call it the blue screen of life. If this was running just a black screen, you might be looking at it and going, okay, is it loaded yet? I don't know, what's happening? But because it is a different color than the default, you know that it's good. You'll also notice some things like I've got this bar around the edges. If I click up here, it brings up the battery and the signal. So it is actually integrated into the UI. So by default, it's not full screen. We'll take a look at that in a second. So let's exit out of here, and we're going to draw some cheese. So if we want to draw some cheese, we have to have some cheese. And I've got this nice, round, red wax-covered piece of cheese. So I'm going to drag this into here. And I actually have to pin the solution so that I can actually access it. Bring it down here, drop it into content. And it's going to give this to me. So here it is. Yeah. That is some epic cheese. If I go into properties for that piece of cheese here, I believe it's Edam. I think that's how you pronounce it. I went onto Wikipedia and listened to a person say it. It was one of the most popular cheeses between the 12th and 16th century because it kept well. So you'll notice right here it gives you the asset name, which is essentially the file name minus the extension, and that it is by default going to be processed and imported as a texture. So you can change some of these things. So if I want to import it as something else, I can do that. I just have to make sure that it is actually that type. Because it came in as a PNG, it assumes that it's going to be a graphic file, so it treats that as a texture. But if it wasn't actually, if I gave it a PNG extension, but it's an MP3, I can tell it something else, but it will fail to build if it's not actually the proper type. All right, so I've got this cheese now, so I need to draw it somewhere. So right up here, I create a new variable for it, and it was a texture, and it's a two-dimensional texture. So I'll say texture 2D, cheese, and I need to load the content, so I do that where? Not in the update. So it's initialize would be if I wanted to make it into a new instance of something, if I wanted to actually initialize the variable. Load content. I'm loading content, so I put it in load content. It actually says to do, use content, this.content to load your game content here. Perfect. All right, so I'm going to say content.load. It's a templatized type, so I'm going to say of type texture 2D. And it wants to know what my asset name is. Item. There we go. I run that. And it took a little bit longer because it was actually loading the content. So now I need to draw it. So where do I draw it? Draw. OK. So in order to draw, these are the textures when drawn onto the screen inside of the game kind of paradigm are called sprites. And you draw them as a batch to limit the amount of sends and receives and everything, the communication that you have to do with the GPU. By far, the most time-consuming thing that you can do inside of a game is send stuff back and forth from memory or GPU. So you want to do it all as a bunch so that it all happens all at once. You can limit the number of calls that you have, and then that's going to save you a lot of cycles. So you begin your sprite batch, and you end your sprite batch. And inside of here, let me close my chat client. I don't know who that was. All right. And then sprite batch dot draw. And it gives you a bunch of overrides here. So basically, it lets you give it just a little bit of information, or if you want to do even more with the actual graphic itself, you can do any of the additional overrides that take more parameters into it, and you can do a bunch of manipulation inside of it on the actual draw call itself. So I want to draw the cheese. So cheese. It's going to give me a destination rectangle. We're actually going to be using this in a couple of the later things, but in this case, what happens is the rectangle chooses exactly where you draw it, and it scales it to the correct size. In this case, I just want to draw it unscaled at the native resolution, so I'm just going to do the next one down, which takes a vector 2. We'll talk about that a little bit more in detail, but it's a pair of numbers with some special cool math things that you can do with it. Yeah, math. All right, so I'm going to say new vector 2, and I'm going to say 100, 200. And a color. So you have the ability to tint your cheese if you want to change the color a little bit, because the red cheese is stronger than the blue cheese. So I'm going to just tint it white, which means that it's not going to affect it at all. One of the more common things that you will do with this inside of games is use transparencies. So you can make stuff fade in and out because it actually supports the full alpha transparency. So you can do that. But let's go ahead and just run this and see what happens. I crashed. I crashed my cheese. Okay, I know what I did. I do this pretty often, so I know exactly what it is. So I loaded my cheese and didn't put it anywhere. All right, cheese equals. There we go. There's my cheese. All right, so it kind of puts it over there. 100, well, okay, 100 this way and then 200 down that way. So you may notice the little starburst effect kind of thing is at the top left, but it's actually at the top right here. It's rotated. That's because the default orientation here is like this for games. Also, you'll notice that here I've got the little black bar that I mentioned, so you can make that go full screen. I'll do that here by going into right after I initialize my graphics. I'll say graphics dot is full screen is equal to true. True. In the French spelling. Okay. And there we go. So now it actually doesn't have these little black bars over here anymore. Cool. So we've got my cheese. I've got it drawing over there. So that's the basics of how you draw this stuff up there. I've got cheese being drawn 30 times a second. So the next thing that we're going to do is take a look a little bit closer to what we want to do with this. So I mentioned that by default it goes to landscape. In this case, we want to change this because we want it to move down. And we actually want to be able to modify the orientation and do some things inside of there. So we'll take a look at how we can do that as well. Also, you'll notice the cheese there is a lot smaller. He's actually using the rectangle to shrink that down, so I'll show how that works. But on this one, you can specify the orientation that you can support, just like I showed on Silverlight, where you said landscape or portrait, kind of how you would be able to modify that. You can bind to methods, so you actually do have events inside of XNA. One of the more common ones, and one that we'll look at today here, is the accelerometer. The accelerometer is actually from the Silverlight side of things. Like I mentioned, you can take sound effects and put them into Silverlight. You can also take things like the accelerometer, which are done with Silverlight, put them over into XNA. So they do talk to each other. So you can bring that over and bind to that event and do something when that happens. So when the orientation change, you can move the origin point, which is the 0, 0 point, is always the top left. So that'll actually move and be the top left for whatever orientation you're currently in. And then for the accelerometer, by default, the orientation is always like this. And that's because if you change it to be like that and then they change the orientation, that would really mess with what you've got because you're moving it around to get the orientation anyway. So you'd have to just do a lot of extra math. So they just said there's an XYZ. It handles it in one specific way, and however you're holding the phone, it's still that same way. And we'll go into accelerometer quite a bit in a little bit further in this session. So the size and the scalar, this is really important. I mentioned that you've got the 30 frames a second, and if you don't have the ability to process within 30 frames a second, or 30 times a second, then what's going to end up happening is your application will skip some of its draw phases. So if you're taking too long to draw, you may actually benefit from just sizing your screen down a little bit and having it automatically resize back up to full. So it can only, so it'll only be doing the processing for a smaller size screen. It actually works really well because you have all of the input, all of the everything that you would have normally been doing. It does all the scaling for you, and that scaling happens on the GPU. So you don't take a CPU hit for that. So your CPU can do all of the processing for a smaller amount of space, and then you get the full screen experience that you would normally get because the GPU is taking that for you. So if you have a game that doesn't rely on very accurate details, most of the time you won't be able to tell on a screen of this size that supports 800 by 480. So you can try that, and a lot of times if you just do that, you might not even notice the difference in the resolution. You'll save a lot of space for your textures. You'll also save a lot of processing for being able to actually move the stuff around. So let's take a look at that. So we're going to go ahead and PowerPoint help. No, I'm good. Let's kill this emulator and build a new one just so that that background process doesn't keep firing off. And I'm going to open a new orientation and scale project to be able to look at this. Okay, so inside of my game, let's scroll down here. So this is where we're setting the full screen and everything inside of here. In this case, so here's that graphics that is full screen. I'll go ahead and remove that one because we've already done it. You have the ability to, if I scroll over here and close this so you can actually read it. There we go. In this case, you've got the portrait orientation. We were doing that inside of Silverlight by saying the portrait or landscape inside of there. In this case, it is an enumeration that you can OR. So you can do display orientation.portrait or display orientation.landscape, and it'll allow for both of them. In this case, let's go ahead and see what happens. First of all, let's run this version of the game. This is not that one. This is the old one. Here's the new one. So here's this. It's set up like so. And it is 800 across by 480 down. I'll jump back out of here. And this one too. And I will tell it that the supported orientation is portrait. See what happens. Okay, so what ended up happening here was it is portrait, but the actual display height and width and everything, they have to scale that down to be able to actually fit that inside of the screen. So you're getting the letterboxing kind of effect. This is now portrait. You'll notice that if I bring it back to portrait, it is in the top left. And you get kind of the letterboxing thing there. And it will do the scaling and all that for you. But what you actually want to do, if you want the full screen, is you tell it that your width and height are backwards from what the default is. And so you'll say your width is 480, your height is 800, and it will automatically scale for that. So that's this thing right here, your preferred back buffer height and width. And if I run this guy, it'll now go full screen and be in the portrait orientation. So you can scale any of these things by reducing the height or width on any one of them, and it will automatically try and take up as much of the screen as possible, doing letterboxing where necessary. So if you tell it that you want to be a square aspect ratio, it'll do it for you and give you those letterbox effects because you told it what to do, and XNA does whatever you tell it to do. So we've got the full screen mode as well, and then we've got the back buffer width. You'll also notice that this, depending on the size that we have, the way that I'm doing the calculation of the size of the cheese, if I stop debugging here and bring that back down to here, on my initialize, in this case what I'm doing is I have a cheese draw position that I'm setting up as a rectangle. You'll remember one of those overrides was a rectangle, the other one that I used in the previous one was a vector. With the rectangle, it'll draw inside of that rectangle exactly, and I'm taking the viewport width divided by 12 as the height and width of this, so it's a square round cheese, and it's going to be based on the size of the viewport that I have, so it'll scale it properly. So we've got that. If you're actually going to be doing this and it's going to be a constant, the best thing to do is actually resize your graphic ahead of time and drop it in there, because every time that you're doing any of these resizing, it is taking a hit somewhere, or you're having to push more over to your GPU. But for this instance, we're fine with this because we're going to be changing a little bit. Okay, back over to here. All right, so we're going to be starting off with the 2D side. We've been drawing sprites already on here. But what we want to actually do inside of here is add some additional gameplay, because right now we've got Looking at Cheese, which is a great game. I like it. Play for hours. But essentially, we've got 2D games that we're going to be building on here. And they are based off of what's called a Cartesian coordinate system, but might not be the same one that you're used to if you've been doing some math. Because computers and math both decided that they wanted to do it a little bit differently. With math, you've got the x and the y, where x kind of goes up as you move up. So you go +1, +2, +3. With computers, you weren't always sure how big your display would be. And you usually start at the top of the screen and go down. So instead, as you go down, you go positive. So you go 0, 1, 2, 3. And then up would actually be negative, generally off the side of the screen. And then same thing with x and with the so your y is up and down, your x is left and right. So yes, when we go 3D, it gets even more complicated. So if we want to look at some of the stuff with the augmented reality, the real world is different than the XNA world, which is different than the math world. So yeah. So we have this one. X goes sideways, y goes up and down. Y is negative as it goes up, positive as it goes down. X is positive as it goes right, negative as it goes left. Yes, that's the actual thing. And what we can do is we can track position, direction, and speed for each one of those objects to be able to move them on a constant thing through each one of those update cycles. So when you're moving things, you have the idea of a vector. I showed you where you could do that as a position. Vector is very versatile. You can use it for a bunch of different stuff. We use it for position. We use it for direction. We use it for all kinds of things inside of here. But a vector is actually, you can treat it in a number of different ways. You can calculate it and you can display it as a pair of numbers, so like an x, y coordinate kind of thing, where you've got your x is the horizontal, your y is the vertical. Or you can do it as like an angle and a magnitude. Or you can do it in, there's other ways that you can do stuff on there. Mostly, in this case, you're just going to only think about it as x, y. And it'll figure out all that kind of stuff for you. The advantage that we have of using a vector rather than using a point is if you're using movement, they've got a bunch of math built into them that you can use just because they're a vector. So when you do a vector dot, you get a bunch of math functions. So in this case, you've got, for example, like 10, 10 would be 10 over, 10 down. You got the 0, 10, it's going to be just 10 down. You don't move anywhere in the left, right. So that's in the directional kind of thing, the velocity on there, rather than kind of the position. You can add them together. You essentially take the tail of one of them and put them onto the head of the other. So in this case, we go down, we go over 300, down 160. And then from there, we move a further 50, 50. So we add 50 to each one of them, and we end up at 350, 210. So they can add very easily. If you do subtraction, you just basically do the exact same thing, but you go in the opposite direction. So it works really well. And you'll notice that it is overridden to the point where you can say vector plus equals velocity vector. So it will add into the system and figure out exactly what to do with the x's and y's. And so these are two-dimensional vectors. We also have three-dimensional vectors. You can do all kinds of stuff with those. And you can do even higher levels of math. And changing the length of a velocity vector is changing the speed. So you can multiply vectors. So you can say, if I have a vector that goes 10, 10, and I multiply it by 5, now it goes 50, 50. That way. Math and computers. All right, so now if we actually add all of this kind of stuff up, we can actually build a cheese that'll roll around the screen. We can do some stuff where it'll actually check the boundaries to do some bouncing. We can do some physics on top of there to do some friction, so it'll slow down. And we have to actually move it somehow, though. So we need to do something with that. We don't have any gamepad beyond like the back button. We do have a keyboard, but only in certain devices. So you don't want to assume that a device is going to have a keyboard. If you have a keyboard, you should have a secondary input, and the keyboard is an added bonus kind of thing. But you shouldn't do anything where you require certain hardware to be on a device because, for example, the keyboard is an optional function. There's some things that you can have in other things with the Motion API. The gyro is an optional piece of hardware that are coming out in some of the newer devices. So you want to make sure that you have support for devices that don't have the hardware so that you have as big of an audience as possible. But we do have a touch panel, and it does have gesture support, so you have the ability to subscribe to some of those gestures. If you actually want to control it directly, you can directly inspect every one of those at least 4 touch points by getting the state of the touch panel and figuring out what's happening with each one of them. Each one of them has a unique identifier. So if I were to take a finger, put it onto the screen, it gives it an ID. If I take a second finger and put it onto there, it also gets an ID. If I remove the second finger, my first one is still there, and it still has the same ID. It's going to be different every time you go through it. So you'll want to be able to do stuff like if you want to do a movement based on the first finger and have another action based on the touch of the second finger, you'll want to say, do I already have a touch point that is active? If so, do something with the secondary input. Otherwise, create that and set that as the primary input. So we'll go into that a little bit more deeply later, but you do have direct access to that. You can also just use the built-in gesture stuff, which is what I'm going to show here. So you don't have to listen to all of them. You can listen to specific gestures in there by saying, I'm interested in this one, and then only handle that type. Some of the ones that you can do, tap, double tap, really useful for zombies, hold, horizontal drag, vertical drag, free drag, pinch, and flick. We're going to use flick. So in this case, we're only interested in flick. You say touchpanel.enabled gestures is equal to gesture type.flick. That's what we want to listen for. Once you've set that one, you don't have to set it again as long as that touch panel continues to exist, which is basically for the lifetime of your game. And we do it here inside of the initialize. You could do it other places, but that's the place that makes the most sense. It could also make sense, though, if you had different menus or different levels inside of your system and each one of them was handled differently, to do it in the different components for that. So let's try flicking some cheese. Cheese flick. All right. Okay, so first thing that we're going to look at here is up at the top. Just some of the different variables we have. We have the texture here. This is where it's going to be drawing. So we've got a vector for the cheese position and the cheese speed. This is the drawing position. And we have a friction so that it'll actually slow down. So if you flick the cheese, it will slow down and stop at some point. Where we update the actual cheese position. Let's see, here's the gesture. So if the gesture type is flick, do something with it. And down inside of update, there we go. Here we go. Cheese position is equal to cheese position plus cheese speed. And then we have cheese speed is equal to cheese speed times friction. So it'll slowly slow down as we kind of go through there. So it's pretty simple as far as physics go, but it's how cheese reacts. All right, so the next part on here is actually bouncing the cheese inside of this same place. Here's the, if cheese draw position .x is less than 0, we're going to swap the speed on that one, so it'll bounce off of this. So you set it to the positive of the speed in the x direction. In this case, you set it to the negative of the speed in the cheese direction. In the x direction, same thing with y. So we're going to be bouncing based on that. And then to actually draw the thing on here, we just have it set up for the cheese draw position and then locate where that's at. And then we draw it. All right, so let's actually look at the gestures part of this. Gesture sample gesture. Touch panel.read gesture. We check to see if it's a flick. And if it's a flick, we set the cheese speed based on the intensity of the flick. So let's try this out and see what happens. All right, so there's my cheese. So I can flick basically you click and then move that around. So this would be useful for like a Pong type game, for example, cheese Pong. And if I let it go, it will slow down and eventually come to a stop. There we go. You can make it go to a stop more quickly by changing the friction here. So if I were to say 0.5, it's going to halve in speed very quickly. Now there's some heavy cheese. I can also do something like this and say 1.01, and if it's a greater than 1, it keeps getting faster and faster and faster. Now, one thing to note on this one is, there we go. Eventually it moves so far off the other side that every time it does an update, it goes past the viewport. So it's going further and further out there and getting faster and faster. So let's not do that, because otherwise we will smash our phone here. Back to normal. There we go. So we got a nice little thing inside of here. All right. We can make this better. One thing to make a game about cheese better is to add more cheese. So we can do that. Quick question, yeah? Okay, so the question or the comment was around we added the speed to the position, but we didn't do anything with the time. So let's take a look at that real quick, because that is an important part if you're actually going to be doing a real game on here. So here is my update function. I've got this game time right here. If I wanted to make it more realistic, what I could do is actually come into here and say, okay, cheese position plus cheese speed, and I could have my speed be in units per second or units per something. And I could multiply my speed by game time dot, so elapsed game time is since the last update, elapsed game time dot milliseconds or whatever we've got in here. You could divide by the amount of time that you had in there. So you could actually multiply it by the slice of time that you had. It usually only comes into play when you are getting less than the 30 frames a second, because that's when you're not getting your full slice in there. If you're getting an actual 30 frames a second, it will space them out pretty properly, so you'll get a consistent view. So if you're going to make something better, do it this way. The other thing to think about here, though, is if you have a large elapsed game time and you're doing some collision checking, you can do something where if you skipped 3 or 4 frames, or there was something where it took a long time to get that update, and that causes you to end up on the other side of the item that you would have collided with, you have to check to make sure that there is, in that straight line, you didn't collide. So it just makes things more complicated, so we didn't do it, but that's how you would do it. Thanks for the question. Good one. Okay. So if you've got more cheese, then you have to do a lot more physics. So there's actually a bunch of resources out there that you can use that are actually built on things like, for the Xbox 360, and just luckily you can use on the phone as well. One of them is the Farseer engine. It's great to be able to use on there. They have a Codeplex project on there, so you can look at that if you wanted to do cheese physics. It's not limited just to cheese. But you can do the collision with other items. Also, if you have a lot of items on screen, there are a lot of things inside of computer science and game design around partitioning the different parts of the screen, so you have to do less comparisons. It's more complex than this talk, but you can look at that to get better performance on there. So the next thing we're going to do is use the accelerometer. The accelerometer is the XYZ. So briefly, as you go through there, my phone disappeared. There it is. It's on a paper. What you get is you have an XYZ that sum to approximately 1 in units of gravity. So the 9.8 meters per second squared kind of thing, which means that for the most part, it'll be 1. But if I throw my phone at someone, that's going to add additional force onto it. So it'll be greater than 1, and when it crashes into the wall, it will be 0 because it stops processing. But there will be times where you're going to get other than expected results in that kind of thing. So you'll want to keep that in mind and take that into account. The other things that you want to do are look at some things like offsets. So if I have my phone set like this, it's hard for me to see the screen. So you might start with your phone like this and use the accelerometer based on that to be able to do some of the manipulation on there. So again, there's some more resources available for the accelerometer, but let's look at the basics of how to make this happen. It's event-driven. I mentioned that earlier around the Silverlight side. And of course, you can save settings. You get the ability to get a timestamp onto each one of them. So the motion sensor, we'll go into this real quick before we do the actual demo. Motion sensor is a new thing that we have with the Mango release. Essentially what it does is it gives you the ability to combine a few different things like the gyroscope, the compass, and the accelerometer to get one block of values back that it's done all the math on it for you. It's a good thing. My phone is way better at math than I am. So I want it to do as many of these processing things as possible. So it'll give you some stuff like the yaw, pitch, roll, the orientation, the gravity that it's receiving, like all of those things, and then you can just come back with it and say, actually use those values for the calculation instead of having to actually compute everything inside of there. So yaw, pitch, roll, rotation rate, direction of gravity. The attitude is the yaw, pitch, roll plus the acceleration of rotation and some stuff like that. Yeah. It'll use the sensors if they're available. If they don't have a gyroscope, for example, you'll get the same functionality. It will just be reduced in precision, but it still works. And I've got some examples there that I can show you tomorrow specifically through my augmented reality samples. Is there a quick question in the back? So the gyroscope is an optional piece of hardware for Mango and is not included in any pre-Mango devices. I have two phones up here which are almost identical. One of them's got a gyroscope, the other one doesn't. I have the same application on both. If you're interested in seeing the difference between the interaction, I can show you that. Yeah, so that makes augmented reality applications pretty easy. So let's take a look at this one. And cheese tipper. Okay. Let's take a look on here. So here's the accelerometer. What I'm doing is I'm actually setting up, let me collapse this down so we can read it better. I'm setting up the accelerometer here so that we have the reading changed event. I'm subscribing to that event. And inside of this reading changed event, I can jump to that. I am taking my X, Y, and Z, and it gives me the ability to do something with it. So once I actually take that, those are the values that I can use to actually update my position. And here's my cheese speed. Let's see, where is the... Should be an update inside of there. Let's run it, show how it actually works, show how you can demo that. And okay. Where is my acceleration? Ah, here we go. Okay, so here's my cheese, and the cheese is bouncing on the bottom. Let me go ahead and expand this out. I showed a little bit earlier how you've got this accelerometer. By default, it's just straight up and down. So if you want to do it, you can say landscape flat, for example. And now it's just rolling flat there, and I can move my cheese around. So let's do it over on the left side. Yeah. So I can bounce the cheese all over the place using the accelerometer on here. The accelerometer and everything that it has inside of here for game development, really easy to see if something would work, really hard to see if it's going to be fun. So you really do want a device at this point to be able to test all of this out. Another thing that's really important on the game side here, kind of since I mentioned that, that part of it with the device, if I'm using touch input, something that's really common is you've got it on the device itself, you're playing with it, you've got a tiny little mouse, and you're doing all of the things in there, you've got a really high precision and not a lot of screen being blocked, you get a couple of thumbs out here, and I can't see much of my screen. So keep those kind of things in mind as you're developing this. All right. So this is where I take the acceleration that I've got on here. So I'm taking the acceleration reading x and y, and I'm actually taking the negative y in this case, just based on how it actually is laid out. The way that I always do this is I put it in there, figure out that I'm going backwards, and then reverse one of them, and then figure out how that works. So that's faster than trying to think about, okay, if I've got the x and it's going in this, no, just try it. So there's that. We're going to skip the next demo on here, but I will talk about this one. So adding sound effects, it's just like when I added the texture onto it. You just drag and drop it into the content. You load it with the content manager. You also have the ability to play back music. It's handled a little bit differently. With sound, instead of like a texture, you're using a sound effect object. With music, you have the ability to do actual play into the media player, which that's where you really want to make sure that if you're going to be doing background music, you ask the user if that's okay first, because the media player is the same thing that is used by like Zune. So if they're playing something and you play something, only one of them can play, so you'll overwrite theirs. So you'll start playing your music, and they'll be mad at you. So we'll skip that demo. We'll go really quickly into combining XNA and Silverlight. We can cover this a lot more tomorrow if you want to see more of this. But essentially, it gives you the ability to do 2D plus 3D or Silverlight UI inside of a XNA app. You take over the entirety of the rendering with XNA, and it lets you do a lot more efficient rendering on that side while still having the Silverlight kind of effects. So you get the shared graphics device manager, so you can actually do some things there. And you do have some good API resources to be able to make it easier to manage. Your game gets abstracted out. It becomes a Silverlight class, but you do get to leverage everything inside of there, so it looks a little different. It's going to be easier just to show you. So this will be the last thing that I've got on here. There we go. So inside of here, I now have 3 projects. I have a Silverlight project. I have a project to be able to interface with XNA, and then I have the XNA content project. So this is the main page that it creates for me. And it essentially has, in this case, just a button that allows me to launch the other one. So change the game page. In my game page, I actually have a reset button, a quit button, and the entire thing here is being handled, like the rest of the content is being handled by XNA. So let's look at the code behind on it. So here's some of the XNA stuff. Here's my content manager. I've got a game timer now instead of being just built into the class. Here's my sprite batch. Inside of here, I use my constructor for the load content. I have a layout updated that I can use to be able to actually do some stuff with the UI elements. My onNavigate2 is where I would actually bring in some of this stuff and actually set it all up. And the biggest thing here is where I am going to current graphics device.set sharing mode true. That turns on XNA rendering. And then here's all of the stuff that I had inside of the other one. OnNavigated from, you have to set that false so that you can get Silverlight back to control. And then instead of update and draw, I have onUpdate and onDraw, and they get called as events. So I'll run this. I think. Run. Yeah, there we go. I've got to actually click the button. Perfect. So here's a game. Click over to the game page. There it is. Bring up this. And sure enough, it moves around. I can reset it to reset the values. I can quit to drop back out. And it has the entire backstack and everything, so that quit button actually navigates back to this page. So if I go back, here's that page again. If I hit back again, here's this. Back again, exits out. All right, so in conclusion, so this is one resource that we want to point at for tombstoning WP7 games. You can do it there. So finally, Windows Phone Platform gives you a bunch of stuff for game development. You can use all of this for application development if you find that this is a better way of doing things for whatever reason. The touch sensor and accelerometer makes it really easy to do inputs into your game, because you don't have a gamepad or always have a keyboard, so those are good options for that. You can really easily add sound and music. you can add anything essentially. It just processes it, imports it, and it's available for you to use. And then you can combine Silverlight and XNA into a single application. That application right there is very similar to just the file new project Silverlight and XNA, but we added all of the cheese stuff into it. Cool. So, Daniel, we've got another slide thing right here. There we go.